Today's lesson is Pre-Algebra Unit 3, Lesson 14, Applications of Inequalities. The homework is page 19 on a word problem worksheet. Here's the other information. All right. I'm going to read this problem. Wayside Middle School has grades 6 through 8. The table below shows the number of students in each grade level. The table also shows the number of students participating in the Walk for Boots fundraiser. If the principal's goal is to have 82 students participate, what percentage of the 8th grade class is needed to meet the goal? I'm going to pause it. You pause this and work it out. All right. So the principal's goal is to have 82 students participate. So let's see how many have participated in the other classes. So in 6th grade, 1/5 of the class is participating. So if I do 1/5 of 110, 1/5 of 110 is 22. 22 6th graders. 0.25 of 108, which is really a quarter. 27 7th graders. So 6th graders and 7th graders, I've got 49 kids. So the principal wants there to be 82 students participating. So 82 minus 49 means we need to have 33 kids need to participate in 8th grade, because if you add 22, 27, and 33 together, you will get 33 kids. Well, isn't a percent always a part out of a whole? So we need 33 students to participate out of 99 in the grade. That's 1/3. And they want that as a percent. 1/3 is 0.333. So it's 33 1/3%, or 33.3% repeated. Need to participate in order to reach our goal. All right, open up your note packet to page 21. We're going to fill in some words here. Inequalities from applications. So words that you would see that mean less than is smaller than, is less than, is under, beneath. Some words for greater than is greater than, is more than, exceeding, and over. All right, those are pretty easy. These get a little more tricky. Is less than or equal to? You could say less than or equal to. You could say is at most. This is the one that screws kids up. Is at most, because as soon as you see most, people think more than. Well, is at most. If I said you're allowed to spend at most $10, wouldn't that be $10 or less? So, is no more than. Not above. Maximum. Some words that mean greater than or equal to. Is, at, least. Again, this is the one that messes kids up, because they say at least would be less than. But think about it. If I said to you, you have to spend at least $10, isn't that more than 10 or the very bottom 10? So greater than or equal to 10. No fewer than. Minimum. All right. Represent each of the following with an algebraic inequality. X is x and y, meaning x times y, xy, is less than or equal to 4. 5 less than a number y is under 20. Now this one's tricky. 5 less than a number y. So if I have $5 less, I'm subtracting 5. 5 less than minus 5. It's not saying 5 is less than. It's just saying 5 less than. So y minus 5 is under 20. So less than 20. Not less than or equal to. The cost of a gallon of orange juice is $3.50. What is the maximum number of containers you can buy for 15? So we need 350x. So let x equal the number of containers. 350x has to be less than or equal to 15. Does that make sense? I only have $15 to spend. So divide both sides by 350, and you get x is less than or equal to 4.3. Well, you can't buy 4.3 containers, so a maximum of 4 containers. Not 4.3. Which statement is modeled by 2p plus 5 is less than 11? Well, the sum of 5 and 2 times p is at least 11. Is at least would be less than or equal to. No, is at least is greater than or equal to. I'm sorry. Greater than or equal to. So that's not right. 5 added to the product of 2 and p is less than 11. This is it. Three more than 5 times the number must be smaller than 93. So let n equal the number. 3 more than 5 times the number. So 5 times the number plus 3. 3 more than is smaller than 93, is less than 93. So subtract 3 from both sides. 5n is less than 90. Divide by 5. N is less than 18. So the number could be 17 or less. It can't be 18 because it has to be less than 18. 17 is the biggest it could be. Mrs. Grabner wanted to buy big tubs of ice cream for the track ice cream social at $10 per tub. She already spent $23 on other supplies for the party, bowls, spoons, and toppings. She wants to keep her costs under 100. How many tubs of ice cream can she buy? So let's let x equal the number of ice creams. So how much do ice creams cost? $10 times x. Plus, she already spent 23. She wants to keep her costs under 100, so less than 100. So subtract 23 from both sides. Your 10x is less than what? 77. Divide both sides by 10. X is less than 7.7. So she can buy 7 tubs. 7 tubs